Okay, thank you. So only the title is in Polish because it was Polish on the agenda, but the presentation is in English, and it's good because I saw someone is actually speaking English, so it's fine for me. All right, so today, first of all, as I was already introduced, I'm a cloud architect at Lingaro, and I've been doing Azure application and architecture for over 6 years now. So most of my time at Lingaro was actually doing that. In free time, I'm also blogging and I have a YouTube. I currently actually have quite a few videos, so if you want to learn Azure, feel free to check it out. So for today, Data Factory, a quick question to the audience. How many of you have been ever using or heard about Data Factory? Oh, good, good. So very briefly, for those who haven't been, Azure Data Factory is a cloud service that was delivered by Microsoft in order to solve classical challenges of data movement and transformation. But for those who have ever been using Data Factory, it was very easy to notice that it was very good at moving data, but very bad at transforming data. It literally didn't have a way to transform data in the cloud. So you could move data and transform it either on a source or a target database, for instance. So you had to employ different services to do so. But recently, about a month ago, to a general public was a new feature released, and this feature is the topic for today. A quick brief introduction also for those who haven't been. Couple of things that are in the Data Factory are classical building blocks. So this is actually a tool where you build everything visually. Version 1.0 of Data Factory was building everything from code. Version 2 is everything through the graphical UI. And the idea is very simple. You build the pipelines. Those pipelines are executed in the cloud. And you connect services. So you build link services, which is this icon with a key. It's basically a connection details. Then you build data sets, which is definition of your schema of your data. So if you're moving persons table, that's going to be a person's data set. And then you just drag and drop building blocks like copy activity, which copies this from one source to another. Data Factory has over 80 sources, actually over 90 now, because it's still growing. So you can copy from various data sources. And it's quite fast at doing that. So what is data flow? And in this case, mapping data flow. I actually had to change this slide because until recently there was only mapping data flow, which was previously called data flow. But there's another data flow that I will show at the end of presentation. So there are two data flows now. So for today we're focusing on a mapping data flow. And this data flow was released a couple weeks ago, around 6-7 weeks ago. And it gives you a visual way to do transformation. So let's say covering the missing piece of what Data Factory had until now. So you can actually transform data now using Data Factory, not only move it. So this is actually a big thing. And amazing thing about it is how it actually works underneath it. Not only is visual, it's similar to SQL Server Integration Services if you've been ever using that. And I will also have some slides referring to if you're migrating from SSIS. But first of all, let me show you how do you create it. I have a couple demos today. Okay, so it's going to be easier for me this way. So in the portal, you hit create resource, and you search for Data Factory. Oh, snap. It's bad because this is actually sliding my mouse, so maybe I'm just going to use touchpad. Hit OK, and just give it a name. You need to pick a resource group. Resource group is just a logical container for your resources in Azure. And you select a region. I always choose North Europe because it's one of the closest data centers to us. But for me, it's the most stable one for the demo, so I really like using that. All right, so we are creating Data Factory now. And in the meanwhile, we're going to be able to also create a storage account. We're going to use a storage account as our source and destination. And we're going to be dropping files there and transforming it. Of course, I could do the demo with an SQL Server, but it's pretty much the same principle. Because Data Factory works in such a flexible way that as soon as it's blob storage, for instance, and it's just a flat file, you change the link service to SQL Server, and suddenly you're uploading to SQL Server. Therefore, there's no magic here. All right, so before I create a storage account, I actually want to go to Data Factory. So I will open here a resource group, so our logical container. Mine is called Cloudina here. And inside I have actually too big of a zoom, so I'm just gonna, I have our data factory that we just created. And to open data factory, just hit author and monitor. And this is gonna open a browser window where you can actually create your data factory pipelines, so your transformations. And this is where you're also gonna be using the, creating the data flows. And the reason why I wanted to create it in just middle of the presentation because of this magic checkbox here, this data flow debug. Because as soon as I click it, I need to wait 5 minutes. So if I would do it later on, I would just wait 5 minutes and try to not bore you to death. So I just wanted to click it. All right, so, and the second thing we're gonna need for today's demo, and reason I'm creating those services from scratch, because I like to show end-to-end demo, that you can actually do everything in a portal in just a couple of minutes. So the second thing we need to do is create storage account. Storage account, as I said, will be our file storage where we're gonna be putting our data in. So I need a North Europe again, because I want our data to be in the same region. I'm gonna call it Cloudina. Is it free? Yeah, it's free, cool. And a local redundant storage and hit create. Don't worry about all the changes. It's just for you, think of it like our cloud drive where we put our files in. Okay, and this is gonna be creating for a couple of minutes, around 1 minute, 2 minutes. And then I can actually go. So this is how easy you can actually create it from scratch. So the service is creating in Azure. And this is how data factory mapping data flow looks. So as you see, it's just the visual blocks, again, similar to SSIS. You just put blocks, join them, create transformation. And as you even see on the screen, you can actually join multiple flows together, save multiple outputs at the same time. And what currently mapping data flows provides are actions, and there are several actions. You have 3 types of actions. First of all, you have multiple input-output, so the basically operation on a stream of data. So you can split data, you can join data, you can union data, you can look for something in data. Additionally, you have actions, those are the green ones now, that are schema modifiers. So anything that changes the way your tables and structure look like. So adding columns, removing columns, transforming columns, and things like that. And lastly, you have row modifiers, anything that modifies rows and rows data. So those are the yellow ones. The reason that I added those colors is because in the portal, when we're going to be creating data flows, those colors will be pretty much similar. And if you already seen Data Factory, you probably remember this, but the usual pipeline looks like this. So you have a block after block after block, and it's just a pipeline. And previously, this was usually copy data, copy data, copy data, and maybe execute some additional stuff. And within that one block usually had, like, I don't know, move data from blob storage to SQL Server. That was good, but also limited, because within that one block, this is as much as you could do. And within data flow is, again, you just replace that one block, so it's just entire data flow is still one action, but within that action, you have that entire flow that I showed you. So it's like a nested flow. That also means that between those arrows, there's no data movement, so that entire data flow has to be end-to-end scenario. So it has to grab data, transform data, put data somewhere. And currently it supports 6 data sources, data sinks. So even though Data Factory supports 80 or 90 over, it currently supports only 6. And there's a reason for that. But the reason for that is that underneath, what is actually pretty cool about it is that you're using some visual designer, right? But underneath this is Spark. Who knows what Spark is? Quite few. So Spark is Apache Spark is a big data technology that allows you to work on very large data sets very fast. It's in memory, it's super fast. And who knows what Azure Databricks is? Pretty much the same people, awesome. And Azure Databricks is a service developed by people who created Spark. So it's even more performant version of Spark. And what this does is you create visual workflow and it compiles it to a package and drops it on Databricks. So even though you designed a flow that looks very simple, you know that underneath there's a very powerful technology. So even if those are terabytes of data, that's going to be just easy peasy. It's just going to grab multiple servers, spread it across Spark clusters, and it's going to go. So it's amazing for, I would say, for small and medium projects, because for the large projects, usually you will want to have more control. You will actually want to write your own scripts. In this tool, you cannot do that. because you have only set defined blocks and you have to use them. So that's why my recommendation for now. And actually, I've been talking to Microsoft Product Group last week on Ignite, because Ignite just finished. And they said that's their goal with this. They want to target small, medium, simple projects. If you have very complicated, big type of projects, that's probably not the tool for you. Although this is very scalable. So if those are simple ones, you can do big stuff here. So currently, those are the 6 supported ones. And now we can actually go to demo. I don't have that many slides. I have actually a couple few after this one. But for now, we can actually go to the portal. All right, I will actually use this one so I can talk and use it. Okay, so the provisioning finished. Right now we have a resource group. And inside of the resource group, we have 2 things. The storage account, so the file storage. On this storage account, I'm gonna create container. And I'm actually gonna create 2 containers called input. Writing with the left hand is super hard. And output. And within the input file, I'm just gonna upload a small CSV file with a movies dataset. And I'm gonna show you how it looks like in a second. So it's just 400 kilobytes. It's about 9,000 rows of data. So very small one, but it shows a principle. But you can be sure that this will actually scale out very nicely. So when I open this and show you edit, as you see, this is a very simple CSV. So it has a movie ID, a title, and a genres, right? So simple 3-column table. And we're gonna use that in Data Factory. So going back to Data Factory, as you see, our data flow debug is running. And let me just explain you why did I do that previously. When you're building data flow in a portal, as you can imagine, you would want to see partial results, like in the middle of that, on the current step. And to do so, you can enable this data flow debug. This will actually provision entire Databricks cluster behind the scenes. And whenever you're developing and you're clicking like debug or show results, data refresh, it will actually send the package in the middle of development to that cluster, run the pipeline on a sample data, and return your results so you can actually see what's happening. And this is actually pretty cool and powerful. But of course, the first provisioning takes those 5 minutes. That's why I wanted to do it earlier. So right now, let's start creating it. As usual in the Data Factory, the first thing that you need to do is create a link service. So it's a connectivity to that blob storage. So from the link service, I'm selecting blob storage. So this is the service that I'm connecting to. I need to provide it a name, so I'm going to call it blob. Snap. All right. And then I'm going to select which one. So I can actually select from my own subscription. So it's, as you see, storage name, Cloudina. It will automatically connect as me right now to the storage account and pull the account key. So it knows how to authenticate, and you just quickly test connection, successful, right? So you are at least sure that your connectivity works. Right now that we have our link service, we can actually start building the flow. So what I want to do today is I want to grab the CSV file that you seen a moment ago, so this one. And in this one, I want to first of all clean this column up, because this column has a title, but also has year embedded in it. So we're gonna do a data transformation that will clean this up. It's gonna have a separate year column and a separate title column. So a very simple one. And then later I'm gonna do a separate one when I will be doing aggregations. All right, so going to the portal. First of all, we need a data set. So right now we have connectivity established. Now we have to say which file from where we're pulling, in this case, movie CSV. So this data set is coming from the blob storage in the format of CSV file. I'm gonna call it movie CSV. I'm gonna select the link service that which is created. So that means grab this file of this structure from this blob storage, defined by this connectivity, and now provide a path. I will provide input and our movie CSV. And of course, that's input movie CSV. Our file, as you've seen, had headers. So I'm just gonna select the checkbox, and I will leave import schema as default. You can validate this works by way you're going, first of all, to schema. Notice that we have 3 columns. So it found out the proper columns. And the second one, in connection, you have this small button here, preview data. So you can actually click on it to validate your loading of data now. So you can validate the format of the CSV is correct. Because you very often will notice, you probably have seen that in a business, that CSV are different. Even though it's CSV and it should be standard, it's not that standard. So, and of course you can change everything that here. That's like a semicolon, not comma, or pipe, delimited, etc., etc. So always verify with this preview button. Now that we have our movie CSV file, we can actually start creating data flows. And here you have data flow section. You click on the three buttons and create new data flow. And this is the first point when I'm actually showing you that there's another data flow. What we're doing right now is mapping data flow, this one. But there's also wrangling data flow, which is currently in preview since actually last week. And I will actually talk just briefly at the end of presentation about it. All right, so we're creating mapping data flow. I can actually hide it, and this is the visual editor that you're building data flow in. So first of all, you always click on the source, because you need to always start from some sort of source data set. And I'm gonna be selecting our movie CSV. And I can actually type movies. And of course, at this point, I can already start using data flow. So if I click data preview here and hit refresh, at this moment is actually requiring this data flow debug. Because what it's currently doing, it's already compiling what you see on the screen. So it's compiling this flow, it's running this on the cluster right now, and it will get results. The first time is longer, because the Spark cluster needs to initialize, it needs to grab required libraries, but the consecutive runs will be faster. All right, so I can actually probably leave it. Oh, we got it. And as you see, this is already the result from the Spark cluster. So right now you are programming pretty much big data technology with just UI. And you got the results. So it's amazing. So, second of all, what do you see here? First of all, let's see what do we have. You have source settings, so you always are able to configure what you're actually using. So you have a lot of information here. I'm just gonna deep dive into that right now because it's not important. I'm just gonna go through the most important ones. For instance, inspect is cool because it shows you the current schema of the data. So within debugging or anything, you can see that at this step, you're gonna be expecting 3 columns, and those are all type string. Why string? Because that was CSV, right? All right, so let's do a simple data transformation. As we said, I need to extract this year, and I need to clean the title. To do so, I'm clicking this small plus here, and it gives me those steps. As you remember, purple ones are multiple streams, green ones are schema modifiers, the raw ones are orange, and of course sync, which is the destination, is blue. All right, so I need the derived column. If you were working with SQL, derived column is just like typing a select. Select some type of expression as, and that's your column. So that's the derived column. And first of all, I need a year column. So I'm gonna type year. So basically a new column in this case. And I need to click here, enter expression. And this will open a visual editor. And this is actually visual editor for writing script in Scala. So Scala is a programming language, one of the programming languages that you can use in Databricks. But in this case, it's Scala. And of course, you have a lot of options here. First of all, you have the most common functions listed. You have some information. But I'm not gonna bother you with scripting in Scala. So I'm just gonna copy the script. What it does is just grabbing the right part of the title and extracting the year. And you can actually verify that expression here by hitting here refresh. So you can even see, again, every time you actually click this, it's again compiling the package, sending it to Databricks, executing entire flow to this point in time on some small sample data, and giving the results. And notice here, output will be this, based on this column. If there's gonna be more columns that you will base on, of course they will be here. So you can verify each one of the column that you used for computation of this column, and the result. So you can hit save and finish. But we also don't need that year anymore in the title. So we need to clean the title. So I'm gonna hit plus, add the title. And right now, I don't need a new column, so I can override the existing one. So a title. And again, hit expression. Just gonna copy the expression, and this again just cuts the title. To verify it works, I just always click refresh. Wait again. it might be troublesome for bigger pipelines, but it's still good that you can actually do it in a browser without having, SSIS installed. Anyone been working with SSIS in the past knows that SSIS works and sometimes doesn't, and sometimes weird things happen. And as you see, it works. So it cuts the title, the output is correct. And we can hit save. So what do you have here? First of all, if you go to data preview, again, you will see the current results with all those dynamic columns now. So this will actually show you the result after leaving this step. What will happen? And notice we have clean title, we have the year. On the top, you see how many rows were inserted, updated, deleted, upserted, how many were lookup, and total 9,125 rows. In the Inspect tab, you can see how did schema change, which is also pretty cool. Because first of all, notice title. Title has a orange, I'm not sure how visible that is, but that's an orange check mark, which shows you that this column was updated. And it's based on a title column. And this new column year is a green check mark, a green dot, and it shows it's a new column based also on title. So you can even see how schema changes on every step using this inspect. And optimize, I will actually go here in a second. So let's actually hit another button and save this to our blob storage. So I'm gonna use the, actually, sorry, it's not the one. So right now we have a data set that is used for loading data. So we need another data set for saving data. So I need to create data set, blob. I want to save as CSV again. Of course, that's, if you were ever thinking also how to easily convert big files in Azure, you can also do that. Just change here the, let's say, change from CSV to Avro, and suddenly your data factory will be just a simple conversion service who's converting files from JSON to CSV. An easy way to do so. Okay, so CSV file, I'm gonna call it movies output. Select the link service. So we're putting on the same link service in output container. So I'm gonna select output, hit OK. I want to, this time the first row as header means should our output have a header? I do want that. And import schema, no, because this is an output, so we're not importing anything. Hit OK. And now within data flow, you can actually start using that. So if this finished, this should be a very simple pipeline that cleans our two columns, right? So we can actually create a pipeline. And this is this diagram that I was showing before. Everything has to be within the pipeline. And one of the blocks that you can actually add there is the data flow. Because as I said, as you saw in the diagram, it's just nested. Pipeline has a step called data flow, and this data flow has multiple steps within. It's confusing at first, but it works this way. So right now you have this button debug here. This debug here no longer uses this debug on the top, because this debug just submits this as a job, normally as a normal data factory pipeline job. The only difference is that you will not see this on monitor because this debug is used to test everything before publishing. And within a minute, we're gonna have a result here. So what I will do right now is actually go for a second here while this runs. This runs for about a minute and 4 seconds. So actually 40 more seconds. So what I want to say, first of all, anybody been using SSIS? Not many. So maybe not an issue for most of us. But if you ever need to migrate from SSIS to the cloud, there are a couple of options. There's a lift and shift scenarios with Data Factory. So you can actually use SSIS out of the box with Data Factory, although it's not very good because first of all, you need to have server running all the time. It's expensive if this is a very small pipeline, but there's a scenario like that. But if you can redesign the flow, you can actually redesign it from SSIS to use data flow. Why is that? Because there's a pretty cool table that Kamil Nowinski created on his SQLplayer.net blog that I like to just copy paste. It has a mapping from what action in data flow is what action in SSIS. So you can see and try to map this all. I would advise just grabbing this entire, because this is actually 3 slides, so you can actually probably try to either print screen this, but he has a PDF on the blog if you need to. And this maps it to SSIS, explain what does the step do, and it also maps it to SQL Server equivalent. If you're just learning, you can understand, if you know SQL, what does it really do. And there's a couple of actions here. One thing, interestingly, I still have it on the slide purposely. There's an extend, and this is equivalent of a script component in SSIS. This step is no longer in data flow. Microsoft removed this step, and they said they removed this step because they want to make sure that data flow is used for those simple, medium cases of the projects. Because in the harder projects, what people would start doing is putting very large scripts in this one single block. That's not how it should be. So they just simply removed it, so it's no longer there. All right, so before I move to this, we can actually go back. So we see our flow right now. And once we debug it, we first of all have success. So we know it ran. Let's confirm on the blob that we have the output. So you can go to output container. And notice this. This is actually a bunch of files. And the reason for that is this is how Hadoop file system works, and this is how this file system saves files, because since this is a big data technology, as you can imagine, it needs to be it needs to know how to spread the task across multiple servers in a cluster. 100 servers, 200, 500, right? And to do that, it needs to be able to split files, split workflows, and later combine it together. And it does it by saving those multiple files. And of course, our result is in this part 000 because we had only one partition, because we only used one server at this time, because our job was very simple. And in the edit, you can see our CSV. So simple transformation as easy as it gets, right? Just click few buttons and you're done. All right, so going back to the data flow, first of all, you have those glasses here. Those glasses allow you to review the flow. So this is like an interactive log session on your data flow. You can actually hit on every single step. You can see what was happening, and you can review. First of all, you can see that we didn't filter any rows. So on every single step, we were working with 9,225 rows. Entire flow took 1 second, 78 milliseconds. So 59 seconds of the overhead, just starting this up, and 1 second of the flow. So just you need to accept that for very, very small projects. But you pay for use. You pay for every single second that this is running. For very small projects, it will be very cheap. And of course, when you click on each of the steps, you can review everything that was happening within this step. So how many columns were inputted, how many were new, how many rows, how much time this took, how many partitions this was. And the partitions are those files that you've seen a moment ago. So how your Spark cluster spread this information across multiple servers. It noticed that our transformation is simple because that's input, and it only created one partition. In the derive column, it also noticed this doesn't need to split data across servers, so it created one partition. And same in the sync. That's why in our output, we had that one file there. And that's pretty cool because you can actually review what was happening. So if I'm gonna close this and actually go to data flow, and let's add one more transformation. So what I will do here, first of all, and by the way, for those who are worried that you have those bunch of weird named files, you can actually change that as well. Just by going to settings, hit output single file, you will actually get notification from Microsoft that you should not do it. And the reason for not doing that is, imagine a scenario where you have 1 petabyte of data, right? If you're gonna make combined data, it's gonna try to load all those data into a single server and combine it into CSV. That's probably gonna run out of memory, because Spark is in-memory technology, so it will actually crash. So this is just for a small project, but it's a nice convenience feature. You just then can type movies clean CSV. And from this point onward, instead of those multiple files, you're gonna get movies clean CSV. And here, I'm gonna do one more cool thing. So I'm gonna hit plus and create new branch. So I'm saying to my data flow, from this point onward, grab the intermediate results and start another workflow in parallel. So in here, what I want to do is do aggregate. And a simple aggregation that we're gonna do, we're gonna count how many movies are per year. Since I already extracted the year, I can now aggregate by the year. So let's aggregate this by year column. Actually, I'm gonna scroll this up a bit. So we're grouped by year, similar to SQL. And in aggregates, what do we aggregate? I'm just gonna call it movie count. And I need to type expression. In case this is such a simple expression, even I can write it. And this will count by year. A very simple transformation. And then, of course, add another sync. Select the same data set, movies output. We can, of course, use output to single file. And I'm gonna call it movies by year. So let's see if this works. Let's hit debug again. And this is interesting because I did that demo 11 times now. And half of that time this runs 6 minutes, and half of that time this run 1 minute. So either I'm gonna run out of the jokes in 1 minute, or we're gonna be sitting here for 5 more. All right, so by the way, notice that everything that I'm doing right now has a star, little star near to it, because I didn't publish anything. And don't ever forget that, because if you're not gonna publish, it's not saved. As soon as you leave this window, you lost everything. So save it. So right now we're running the data flow, and this should save 2 files. I will actually run to the blob storage in the meanwhile. I will actually refresh it because there's a big chance that it already did run. And as you see, movies by year, movies clean. Of course, it didn't remove all the files because it doesn't do that. Movies clean, edit. As you see, that's our movies, the cleaned up data. And you have movies by year, edit. And you have year and account. So this is how simply you can actually run those transformations using data flow. And of course, as I said, you're gonna pay for every single minute of it. As you see, it's still running, and mostly because it ran in that 1 second that we've seen previously, but right now it was shutting down the cluster. That's why it ran in 1 minute, because it took 50 something seconds to shut it down. And again, hitting glasses, you can review. In this case, first of all, the dots. The dots indicate how many parallel workflows was running on this particular step. Notice that 2, 2, and here 1, right? And notice something interesting. It created 199 partitions for this particular step. As you can imagine, for a file with 9,000 rows, that's not ideal. Because what's the point of creating... And by the way, it calculated only 105 unique rows. So it had more partitions than it had unique rows. Because this is how Spark works. It tries to, if you don't select anything, it tries to guess, based on the workflow that you're doing, how many partitions there will be needed. But what is good here is, and by the way, if I wouldn't select that checkbox, save it to single file, right now I'd have 195 files on a blob storage, one for each partition. So what is good here is that if you will actually go back to data flow, it does allow you to control that. So on this derived column here and on the aggregate, if you remember, that was the step that had 195 columns. You can actually control that. I didn't want to show it at start, but you have an optimized tab here where you can control how in this particular step Spark will be doing the partitioning. So you can either select single partition, again, warning about memory, because it will not spread across multiple servers if you do that. So make sure to do that only for very small data sets. But you also are able to create set partitioning and create select an algorithm which will be used to create partitions. So you can do round robin. So in this case, you say create 2 partitions or 5 or whatever. You can do hash. You can do dynamic range. You can do fixed range. So if you know those are by year, maybe you want to make sure that partitions are by every 10 years. Or you can do by key. So just tell him to do it by year. In which case there would be 105 partitions. That's pretty neat that you are able to actually control that. But in our case, in very small projects, single partition is just fine. And if I would just run it again, I would get the same result because nothing changed. I was just combining result. And this is how it was working. All right. So, and of course, after everything, just publish all. You don't want to lose your information that you just created entire flow. All right. So going back to the presentation, there's another data flow. I'll actually use this one. So there's another data flow called wrangling data flow. Wrangling data flow is, anybody been using Power BI? 1 person, 2 person, 3. Okay, 6. Good. In Power BI, there's a tool called Power Query. Power Query is known that it has originated in Excel as a Power Query Excel add-in. Then it became an entire tool, and then they added it to Power BI, and then now it's in Analysis Services. And now it's also in Power BI called Data Flows, and which is actually pretty confusing because it's not this data flow, it's called Data Flows, which is not a singular, it's a plural form. It also doesn't have a space. So this is data flow, 2 words, that's data flows. Makes sense, right? So in Power BI, data flows is basically Power Query in the cloud. And Microsoft did the same here with Wrangling Data Flow. So Wrangling Data Flow is your Power Query in Azure Data Factory. And I was also asking Microsoft Product Group about this feature. So where this is directed, to which kind of users. And they said, this is for the most simple cases. So if you want your power users, maybe your data scientists, explore data, transform data on their own, you can actually allow them using this. But there's one very cool thing here that is, well, you can find it in the documentation, it's not here, is that underneath Power BI, the M language is actually evaluated as M language in something called mashup engine. And anyone who's been doing anything bigger in Power BI knows that this mashup engine is very ineffective. As soon as it's gigabytes of data, it crashes, runs out of memory, has problem with loading multiple data at the same time. The difference here, Wrangling Data Flow, even though it looks like a Power BI Power Query, exactly the same, it's, well, almost the same UI, almost the same feature. It even allows you to copy-paste from Power BI your M language queries. The difference here is that this is also compiled to Spark. So they created some sort of magic transformation layer underneath that grabs your transformation from M language and changes this to Spark transformations and runs it the same way as it runs data flow. That's why it's also called data flow, because underneath is the same technology, the Spark-based. But the UI is different. It's the most simple one. And this is also the most convenient for people because you actually see the data on every single step, right? So you just do transformation and it works. And of course, well, I wouldn't say this is a migration path from Power BI because that's not the point. Although you could try to do that, there's few sources still missing. So be careful about this. All right. So one last thing that I wanted to show you is actually there's literally no point, but everything that you created is also saved as a code. So if you do those transformation, you can actually generate script to grab everything from this data flow. So this is easy for operation migration purposes if you're moving to another environment later on. So of course, if you're doing CI/CD operation and stuff like that, you have ability to actually move this across environments. All right. So I have like a next steps for you guys if you want to continue using that. First of all, Data Factory documentation is really well done. There's so many examples. For instance, the most common example that I get from people in my company is like, how do I do incremental loading with Data Factory? And literally, if you type that in Google, you get first link on MSDN documentation, how to do incremental load, and there's like 10 pages of the book written down step by step with queries, example from SQL, how to do that. So it's a very well written documentation. You also have Channel 9, which is hosting Azure Friday videos. So that's by Scott Hanselman. He's doing a lot of videos. He has entire series on Data Factory. There's also blog. So all the news, if you want to see what is happening, what they're thinking, what they're doing with data flow, it's on their blog. And of course, if you want to visit my channel, I also have videos. I have currently 4 on Data Factory. So for those who haven't been using Data Factory, if you're interested in what you've seen and you want to actually start using Data Factory, there are end-to-end introduction videos that I have there. You can actually start from very beginning. And that's it. So maybe any questions?